Okay, 12:05. So let's go ahead and get started. RRF is the code. Okay, close that. Close that. All right, so this is number 45 from that same ACT. I'll give you 3 minutes to try it. Okay, so let's go over this one. So there are two different ways you can solve this. What I did is I started with this first equation and solved it for x. And when I solved it, this is where I was talking about. There's two different ways to solve that. I'm going to end up showing you both ways. But the first way is, I think, the more straightforward one. If I want to solve this for x and get x by itself, I don't want it in the denominator. So how do I get it out? Well, instead of dividing by x, I will multiply. And if you do that to both sides, it'll cancel out over here, leaving you with just 3, and then 12x on the other. Divide both sides by 12, and you get x is a quarter. You can then take that, plug it into the second equation to find out what y is. All right, let me show the other way to solve an equation that looks like this, where your variable is in the denominator. To solve this, you could just make the other side a fraction too. And whenever you have a fraction equals a fraction, you can then solve it by cross multiplying and then divide. So you'll get 2 times y equals a fourth. And if you divide a fourth by 2, you will get an eighth. Because we don't like fractions within fractions, so to fix that, we multiply by the denominator. And the top, the 4's cancel, leaving you with 1. And the bottom, 2 times 4 is 8. So the answer is A. Yay? Okay. Yeah, looks like everyone put A. Or they changed it to A while I was working. I'm sure you got A at the beginning. Questions on the bell work? Okay, today is going to be a relatively easy day. There's going to be a lot of, whenever we really start a chapter, there's a lot of vocab and that kind of stuff at the beginning. And we're kind of going through that lesson today. 4.1 actually has got kind of a lot in it. So we're only, I think, going to get through this, and then we'll start C, but not finish it. And then D, we're not going to get to at all today. So we're going to continue with 4.1 for Wednesday, which means the assignment's really not going to be due till Thursday. But I still need to update that in Tyler and WebAssign, or Classroom and WebAssign. But no homework due Wednesday. It'll be due Thursday instead. Okay, let's do it. How to describe angles. So here is what you need to have in your notes for the parts of an angle that we're going to care about. And you might not need to include all of these. If you already are pretty familiar, but if not, it doesn't hurt to write them down. All right, so when we are given an angle, pretty much for the rest of this class, we are going to assume that that angle is in standard position unless we're told otherwise. What I mean by standard position is that the vertex is in the origin of the xy plane. So it's at 0, 0. And one arm of the angle, which we'll call the initial side, lies along the positive x-axis. The terminal side then lies elsewhere. This is an example of an angle that's in standard position. Vertex at the origin, 0, 0, and the initial side or one of the arms along the positive x-axis. When your angle is in standard position, we differentiate between 2 types of measurements. If your angle is produced by a positive rotation in the counterclockwise direction, like this example right here, we're going to label it with a positive number, and this would be like about 135 degrees. However, you can also describe an angle using negative angles if you imagine that your angle is turning clockwise. So this would be an example of a negative 45-degree angle. The easy way to keep those directions straight is by the quadrants. If you are counting up from quadrant 1 to 2 to 3 to 4, right? That's counterclockwise, then your angle will be positive. But if you're going 4, 3, 2, 1, if you're going clockwise and you're counting down with the quadrants, then your angle would be negative. All right, the last vocabulary term that you need comes with these two examples, and these examples are called coterminal angles. Two angles are coterminal if they look like we have in this picture, where they share the same initial side and they share the same terminal side. They start and stop at the same spots. So this angle alpha would be a positive angle of about 225 degrees. That angle is coterminal with angle beta here of, what would that be, negative 135 degrees. There's actually an infinite number of coterminal angles that start at the positive x-axis and end here. That's kind of illustrated by this second example. So you can see that angle alpha here is 45 degrees about. But angle beta goes completely a full revolution and then continues and stops at that same spot. So angle beta is 405 degrees. I can make another angle theta by doing 2 revolutions and then continuing and stopping there. Or I could do 3 revolutions and then stop here. So long story short, you can find coterminal angles by adding 360 degrees to your angle or subtracting 360 degrees from your angle. So for our examples, 225 minus 360 gives us negative 135. 45 plus 360 gives us 405. And you can keep adding 360s and keep subtracting 360s to get more and more coterminal angles. I don't have any tea. This cup is empty. This is marinara sauce. That's a gear. All right. Questions on the vocab stuff. No, I'm not going to drink the marinara sauce. Well, it's not bad marinara sauce. It's pretty good. All right, does anyone need more time to write, or are we happy moving on? All right. Okay, so that's how we're going to talk about angles. Now let's talk about radians. So hopefully you've encountered radians before. I actually don't know, to be honest. I don't know if Miss Waters would have done it in honors geometry. I think I did it in regular geometry, but just like for not even a full class period. It was just like, hey, here's radians. This is how they work for like 15 minutes. And then I think they cut it out of algebra 2. So this might be just all new to you. But a radian is just a different way of measuring angles. It's a different unit. So You know how when you measure temperature, you could do it in Fahrenheit or Celsius? When you measure the length of something, you could do it in feet or meters or centimeters or yards, whatever. When you measure angles, there are two units of measure you can use, or that we'll use, degrees and radians. A radian is a mathematically defined interpretation of what an angle is. It's based off of, we could say that this angle, theta, will equal the arc it intersects, S, divided by R. Such that 1 radian will occur when the arc length is the same as the radius. But really, this is the most important thing you need to write down. They're going to ask you questions about coterminal angles on the homework and on the ACT. They're going to ask you questions that require you to use this formula on the homework and on the ACT. And how it'll generally work is they'll give you 2 parts of this formula and ask you to find the third. So they'll tell you the arc length S is 5, the radius of the circle is 3. What's the central angle that intercepts your arc? And it would be 5/3 radians. Or they'll say, like, you have a central angle of 3 radians with a circle that's radius 10 feet. What arc is intercepted by that angle? And then you would solve it for S by multiplying by 10 to get 30. Right, so it's not too bad to solve it if you know the formula, because you just plug in the 2 numbers and solve for the third. All right, do we have questions about the definition of radian? Or does anybody need some more time to write things down, perhaps a journal? Perhaps you started a new journal for the second semester. You have second semester written on top of it. There's probably a rainbow on it, because this class is always, bursting with joy. That's a rainbow. You can ask anyone. You show them that picture, you say, what is it? They're going to say a rainbow. Oh, hey, we got him. We got a live one. Okay. Boom, 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 boom. By the way, I believe I just posted the grades for semester 1 for this class, and I think not a single person even got a D in this class. I gotta say that now. If I lied, I'm gonna feel bad. Nope, not a single person even got a D. So good job, all of you. All right. Okay, last thing of notes, and then we'll start actually working on some problems. So what we can conclude from that previous slide is this slide. This slide follows directly from it. You can deduce everything that's on this slide from the last one. The most important deduction that basically all of the rest of this falls off of is that means that 360 degrees is the same as 2 pi radians. I know what you're thinking, Mr. Lake. How? That's impossible. How could that be? Well, imagine, if you will, that you have a coordinate plane, okay? You have a circle at the center, and let's just arbitrarily decide that this circle has a radius of 1. It'll make our math easier. It doesn't actually matter what the radius is. It could be 5, 10, it could be 2.3. Doesn't matter. And let's say I want to find the angle that is created from a full revolution here in radians, where I go all the way around. I want to find this angle. Well, I am told that the angle in radians is the same as the arc length divided by the radius. The arc that this angle would intersect, again, would be, since it's a full rotation, the arc would be the full circle. So for this problem, what's kind of strange is the arc it intersects is the same as the circumference of that circle. And we know how to find the circumference of a circle. Pi r squared sounds like area to me. And if you need the circumference, just do 2 pi r or pi d. And again, for our circle, the radius is 1. So this is really 2 pi times 1, which is just 2 pi. So if I plug this in for s and this in for 1, we get that the central angle is 2 pi divided by 1, which is 2 pi radians. Gasp, shock, no, impossible. What? How? Okay, you don't need to actually memorize or be able to do this proof by yourself. Really, you just need to know what's in the box here. 360 degrees is the same as 2 pi radians. I was going to say something else I forgot. Oh, let me answer a question that you're already asking. Mr. Lake, what is this arcane symbol that you have drawn here? That is an S. You say, wait, Mr. Lake, what the heck is this thing? That is a twirl, because that is not the number 5. Everyone agree that those aren't the same? And if I drew this, you don't know if that's a 5 or an S. This is an S, that's a 5. Yay? All right, I know you were all dying to know that. Okay, now, if 360 degrees is 2 pi radians, that means that 180 degrees, right, a half circle would be 1 pi radians. That would mean that a quarter circle, or 90 degrees, would be pi over 2. And that 270 would be 3 pi over 2. So this conversion rate here basically tells you all of the information you can pull here. If your angle is between 0 and pi over 2 radians, that is equivalent to 0 to 90 degrees. If your angle is between pi over 2 and pi radians, that means it's between 90 and 180 degrees. Pi to 3 pi over 2 would be 180 to 270. And 3 pi over 2 to 2 pi would be 270 to 360. Questions on this? Does anyone need more time to write? I got 4 hours of sleep last night. Willow wanted to be up at 5 a.m. and not sleep much before that either. All right. Yay. All right. So now so I've given you a whole bunch of information. We're now going to start applying that information to different things that they're going to ask us about. Now, I believe the first type of questions that you get on the homework, and you'll see these on the ACT too, is they'll give you an angle. They'll tell you to find a coterminal angle, either like the next largest one, or find a negative coterminal angle if I give you a positive, or whatever. So if I'm given this angle, 13 pi over 6 radians, and I want to find an angle that's coterminal with it, you already have this in your notes from today, but I'm going to write it again in case you missed it earlier. In order to find a coterminal angle, you simply add 360 degrees or subtract 360 degrees. Again, if they don't give you anything specific, you get to pick. Now, my problem's in radians, so I don't really want to add degrees. I want to add 2 pi radians or negative 2 pi radians. So for my problem, if I want to find, let's say, the next largest coterminal angle, I'm going to take 13 pi over 6 and add 2 pi. Again, I just arbitrarily picked. I could have subtracted 2 pi. I could have subtracted 4 pi. It doesn't really matter based on the instructions that I was given. So if I'm going to add these together, I need a common denominator. So if I rewrite this as a fraction over 1, I need its denominator to be 6. So I'm going to multiply by 6 to the top and the bottom, which gets me 13 pi over 6 plus 12 pi over 6. And 13 pi plus 12 pi is 25 pi over 6. So this angle will start and stop at the exact same spots as my original. They are coterminal because this is just one revolution extra than the original. If it asked me to find the next smallest coterminal angle, well, then I would have subtracted instead. And you do it the same way. Get a common denominator. That'll be 13 pi over 6 minus 12 pi over 6, which is pi over 6. If they asked me to find a negative coterminal angle, I could just subtract 2 pi again till this becomes a negative number. But again, what my work is telling me is that all three of those angles will basically look like this. They start on the x-axis and they stop at pi over 6. Where the 13 pi over 6 is like a full revolution, and then it goes to the pi over 6. And the 25 pi over 6 actually does a full revolution, then another full revolution, then it stops at pi over 6. I still don't have any tea. Believe it or not, this cup is still empty. There's no tea in here. All right. Questions about the example, or does anyone need more time to write? Okay, then I'm going to give you some problems to try on your own. So here are two angles in radians. Find any coterminal angle for each one. Could be the next largest, could be the next smallest, could be, 3 full revolutions ahead of the other. I don't care. I just need any coterminal angle for each of these. I'll give you 3 minutes. Oh, heads up. At the end of these 3 minutes, I'm going to call on 1 or 2 people to help me out. They will be the 1 or 2 people that haven't responded to this practice question, either in Pear Deck or in the Zoom chat. So if you end up not responding in these 3 minutes, you're probably going to get called on by me. All right, anyway, 3 minutes. Okay. Let's go over it. Oh, it's not. Okay. I know what the issue is. All right. Hey, I'm lacking some responses. Good. I'll have some people to call on. All right. So, nope. No, not yet. All right. So I think the best way to do this is we'll just go by and see who didn't respond yet. Hayden, Mr. Eddie. All right, what do you think I should do for this first one here to find a coterminal angle? What do you think, Hayden? What should I do to find my coterminal angle here? I just got binged. What was that bing? Oh, is that a chat? Aha. Okay, so yes, the idea here is you want to add or subtract 2 pi. Which, again, you need a common denominator, so multiply by 4. Joop. Joop. That gets us 3 pi over 4 plus 8 pi over 4, which is equal to 11 pi over 4. Okay, for this second one, you could do the same thing, or you could subtract by 2 pi. But I'm going to go ahead and add 2 pi because, you know, sometimes it's easier to just do things one way and just stick with it. You know what I mean? Don't need to change things up. Every once in a while, you know, I always think it's very tempting to just teach things one way and not, you know, worry about, okay, there's 3 different ways to do this problem. Let me show you all 3, then you pick the one you like best. Right, I could just do one and then force everyone to use that one method. But I found over the years that it's not as effective. All right, questions about the bell work? Or the bell work, the guided practice? Any issues finding these coterminal angles? Okay, that's great. All right, the next thing that you're going to ask to be they're going to ask you to do is to convert between degrees and radians. And really, this is the last thing going into your notes for today. And really, all you need is this. To convert from degrees to radians, you just multiply by pi over 180 degrees. You want your target units on top and your starting units in the denominator. That way, when you multiply degrees by this, your degrees will cancel out with the degrees in the denominator, and the only unit you would have left then is radians, which is what you want. Similarly, if you want to convert from radians and end up with degrees, you multiply by the reciprocal, and you want the 180 degrees on top. Down here are 6 angles that are considered so common that you would have their conversions memorized. Like, for example, they wouldn't want you to work through this and take 30 divided by 180 and then say, well, 30 and 180 are both divisible by 30, and it goes into it 1 over 6 multiplied by pi makes pi over 6. They would just expect you to have that memorized. Pi over 6 is 30 degrees. Pi over 4 is 45. And pi over 3 is 90, or 60 degrees. Pi over 2 is 90. Pi is 180. 2 pi is 360. All right. And so tomorrow for bell work, or Wednesday for bell work, we'll go through and do some of the conversions. And then do some real life problems. That'll be Wednesday's class. Um, once you're done copying this, it is 12:45. So if you want to log out and head out to your third hour, that's great. If you have any questions or need any help, please let me know. Okay, so stop share.